Hello everyone, welcome back. In this video, I am going to tell you how to reproduce the result in PyTorch environment. Getting the same result over multiple execution is very much important in any research field to understand the experiments that you design is actually working or not. If your base result itself will keep on changing, you cannot validate your new approaches. So deterministic behavior for any machine learning model is very important at a point, especially when you have to conduct several experiments. This is one of the issues in PyTorch where it is very difficult to reproduce the base result in every execution without doing any modification under normal circumstance. And I'm going to tell you can you fix that so that you'll have a fixed base result on top of which you can conduct the experiments. Just to give you little more background on PyTorch if you are new, PyTorch is one of the most recent and highly getting popular deep learning platform. There are other platforms also like Keras, TensorFlow, but PyTorch is one of the very adopted one right now because of the fact that it supports cudas. Now, what do you mean by cudas? Cudas are a collection of highly GPUs. So GPUs are nothing but graphical processing unit. In simple to understand, GPUs helps you in faster execution on numerical operations. So CUDA supports that, and hence CUDA makes deep learning execution very, very fast. But along with the CUDA support, this problem of reproducibility comes along with PyTorch under normal circumstances. And how do you know about that? So if you go to PyTorch discussion platform, you will see a lot of questions similar to the one you see on my screen. The same seed, but a different running results on two executions. Document inconsistency in DataLoader and Torch initial seed. Two models with same weights, different results, and many more similars. What this all article is about, this all are telling us that see, I want to get my base result fixed every time I run my code if I have not made any extra change or any change. And that has been one of the main problem with PyTorch and especially in the experimental environment, as I said before. So I'm going to tell you what PyTorch has provided to solve this problem and what extra you need to add on top of that to actually solve this problem. So what PyTorch has provided so far is not a complete solution, and that's the reason people still face this issue. I have done my research through various ways, and finally I have come up with a one-point solution for this problem. You do not have to here on go to searching multiple articles on internet. So I have tried, and this solution what I'm going to share with you is a proven one. I'm already using it in my system and I am able to reproduce my results after every executions. Has a document provided to that helps you basically to set up the reproducibility of the result, and the document is the one you see on the screen. Well, it has said a lot of things. To summarize it, it's asking you to basically set your seed variables and then basically set your cuda's benchmark to false, and then also set your backend CUDA NN to deterministic as true or false. We'll just see in some time. Along with that, it has given some more instructions, especially for CNN, to do this seed worker seed setting. Now, what is the use of this and the data loader? I will tell you all in detail in some time. So, but whatever information here is provided is not that easy to understand and also not complete, let me tell you. Like any other internet source, the main document itself is not complete, and for any beginner, it would be certainly difficult to follow this article because it's too technical and actually too much of information is not provided, and that's what I'm going to help you with and give you a complete information. If you scroll on internet and if you look for the regions, possible regions that due to which the results could not be reproduced in PyTorch, you may find answers related to random initialization of weights. So for your deep learning models, what you build in PyTorch, once that object, deep learning object get initialized or your model get initialized, it gets assigned with random values. Now, this could be one source of non-duplicability, but that's not true. So I'm just highlighting here the points that are considered to be the main reason because of which you cannot reproduce or replicate your result, like batch normalization or dropout randomness. So dropout actually switches off certain percentage of your nodes, and those are all random. You may not know from outside which all nodes are switched off. So these are certain myths that's actually there on the internet, but I would say do not follow. There are the other reasons because of which the results could not be replicated in PyTorch. So what I'm trying to say is do not try to put your effort in solving these issues which actually do not lead to the main issue of reproducibility. Let's directly jump to the main regions. And in that regions, I'm going to tell you what are the root sources of the randomness that comes into PyTorch, and we should work and try to fix them. Yeah, so I have listed out the complete list of the randomness that we must handle to ensure that our results are deterministic and we have always a fixed base value, right? So there are six total sources of deterministic, uh, broadly to summarize, but there could be a lot more if you have customized anything from PyTorch. I will talk about that too. Let me start with the cuda's randomness. So whenever you use cuda's, that means your collection of GPUs, that also adds a lot of randomness to your data, and you have to do something about it too. So remember, whenever we are going to fix the randomness or reproducibility issue, we have to also deal with cudas. So you should be aware of the cudas of your what sort of randomness objects are used in your cudas. Okay. Next, workers randomness. If you have worked with PyTorch, you must be familiar with the DataLoader object. DataLoader object takes one of the parameters called workers. So workers is basically helps to signify how many cores of your system should be used. So in our system we have multiple cores. So a lot of the time, to make it faster execution, we try to use multiple cores. And whenever the data is distributed across these cores, what happens? A random selection happens. So that also leads to one of the main reason for non-reproducibility of the result. So we have to fix there too. The third could be the data loader itself. So data loader also has a logic in itself to, to select your records in each of the batches in random order. And how is that handled? So that is handled via the shuffle parameter. Whenever you have set the shuffle equal to true, what it does down the line, it tries to select your records into batches in random order, or you can say that follows some sort of random shuffling. So if you do not want to again introduce that random shuffling, you have to set this shuffle as false and pass shuffle as false in the data loader. Next one is Numpy randomness. So if you are using any code from Numpy source while doing your data preparation before passing to the model, and a lot of the time this PyTorch models also make use of Numpy random objects like Numpy random seed. So you have to make sure to set a seed for this Numpy randomness too. Python randomness. A lot of the times in these packages, PyTorch methods. Random.seed object is method is also used. So please make sure to seed this object too. Apart from this known and common standard randomness, there could be some extra randomness that you may have used in your code explicitly. Like one could be like NumPy random permutation and some any more. So if you have any other randomness added to your code apart from till point 5, you have to seed them properly. And while seeding them, you have to make sure you seed all of them with the single constant. Now, there is little more coding required rather than just seeding this object. I'm going to tell you that too step by step in some time. Before that, let's take care of one more fact. So whenever we are fixing this randomness, it could not be straightforward. So I have tried to break down them into steps. And for each of these steps, I'm going to show you the sample code too. So broadly, what you are supposed to do to fix this issue of non-reproducibility, sorry, is first you create a common script where you call all this random object and you seed them with a common value, and you make sure your seed remains fixed on a system. I will share the code too in some time. Then you call this set of codes in form of a script to every related files of your Jupyter, of your model. So whenever you have a project on some classifier or regressor, you have to call this or set this seed in every file explicitly, that the task will be yours. If you miss, the randomness issue cannot be fixed completely. In the data loader parameter, very explicitly, you have to again set the shuffle parameter to false. And then if you have any custom data loader designed, a lot of the time PyTorch do not expect us to write our custom data loader to load the data to the model. So, and there if you are using any randomness, that too we have to fix explicitly, seed it with the same constant. Now, so this also I'm going to show you the code just in few seconds. Before going to the code, you have to make sure you know in and out about the code or the project code that you are working at, and then only you'll be able to take care of all this randomness. If you miss even one, you are going to lose. And if you just follow these steps completely, you do not have to fix the randomness in the weights part, as I discussed earlier, that the weights or your batch normalization or dropout, those randomness is actually already taken care by PyTorch. We don't have to take care to maintain the reproducibility. Only these are the extra things like cuda's randomness or DataLoader randomness that we should worry about, and that's what we should confine to. So, and do not as there is no documentation that says that you should fix the randomness of weight assignments or your batch normalization or dropout. If you fix them, the results that you may get cannot be explained, and even if it looks or maybe coincidentally come out to be very correct, that cannot be relied and that cannot be trusted. So do not fix them until and unless you know how the behavior will change fixing them. Let's see the code and stepwise process of what all code you need to write to the minimal to handle this issue. First, I'm following the modular approach, and hence I would recommend you to write a script. Let's say I call that reproducibility.py. So in a script, you go ahead and set for all this randomness we discussed, set the seed. I have chosen a 42 as a value, which is mostly a standard value if you see any machine learning package and their documentation. However, you can set it to anything, even 0, but you just have to make sure you do not change it once you set to 0 or any value that you choose. And then once you have done that, you have to make sure to set your cudas.benchmark to false. and then cudas.backends.deterministic equal to true. Now these two are very important flag. A lot of the time, if you have ever used the old version of PyTorch, there was an alternative to deterministic second argument line 7, and that was something torch.use deterministic algorithm or set deterministic. Now these two are outdated. So if you see this code anywhere, please just understand that that was related to the deterministic setting of the CUDAs. Now, if we are using GPU or CUDAs, we also have to make sure that we set for CUDAs all the manual seed as set to that particular seed. And likewise, torch.manual seed also has to be set to the same seed, random numpy random.seed, same seed, and random.seed, same seed. Now, these are the few standards that's known thing and even used heavily inside your PyTorch. If you are using any external package or source of randomness in any of your code, you have to include those two in these scripts, and these are very important. So once you have come up with your reproducibility.py, what you are supposed to do next is call it in every other script that you have in your project. Very easy way to do it would be importing it. So you can import it, and then this all seeding will happen. The constant will be applied in all of your files, and it's always best practice to do that. Once you have done that, we also have to additionally handle the data loader shuffling. So in data loader, there are three important things we are supposed to do. If you miss them, your reproducibility cannot be still handled. The very first thing that you are supposed to do it, you have to set your shuffle equal to false. What happens when you say shuffle equal to false? In this case, for your training set, now this is applicable to any data set, even validation set, but right now I'm talking with reference to a training set. So let's talk about we have the training data set and we have to divide it into multiple batch. So what will happen from your training set, the data will be taken in random order and divided into multiple batch. If you do not want to select it in a random order, you can set your shuffle as false. So in that case, in sequential or fashion, your data will be broken down into multiple batches. Once you have done that, you are also supposed to do something about your workers. As I said, the workers is specified and related to the number of multiple cores used in your system. So while the whole data is distributed into multiple cores, there also some sort of shuffling happens. And if you want to skip that shuffling, you have to pass two parameters explicitly to your data loader. And the two parameters are basically your generator parameter and worker init parameter. The generator parameter takes a torch.generator object, and you have to, for this generator object, you have to manually seed it to again your random set. This is very, very important step. If you skip this step, you are still going to not reproduce your base result. So this makes sure that whenever the data is further splitted across the workers of same seed is fixed. In addition to that, we also have to pass this worker init function. Now, in this function, we are going to take all the torch initial seed and set it to this particular value. Our random seed and the random numpy random seed is set to the torch initial seed. And what will be the torch initial seed? So that will be again your random seed. So indirectly, we are making all sort of seed inside the data loader to our constant random seed. So these are the three important parameters that you must handle to make sure your data loader also produces deterministic training sets. Once you have done this, you are sure to get a deterministic behavior in your training and prediction set. And this will help you to reproduce your results every time whenever you work with PyTorch And I hope this is helpful to you. Till then, keep happy learning.